Bitlocker performance impact on SSD. I've put a brand new SSD into my work computer and my department wants me to use Bitlocker. I read one of the other threads on Bitlocker performance on standard hard drives, but I was wondering, what's the performance impact of Bitlocker like on a solid-state drive? Will it noticeably impact the speed with which I open my archive files in Outlook or open projects in Visual Studio?
You should have a negligible performance impact with most SSDs. Especially with the latest Intel CUS that can do hardware ICE way faster than a drive. Any drive can read or write. My MacBook Pro pushes over 900 megabytes per second with ICE according to the TrueCrypt benchmark, and that's a laptop. On my desktop I use 4 Samsung SSDs in RAID 0 and I have Bitlocker turned on. TrueCrypt on this same machine reports over 5 GB per second for ICE. 2 6-core Xeons. That said, the SandForce SSD controller is said to do some internal compression/dedupe, which was proven via benchmarks that used large compressed files that it could not optimize. Obviously this is not going to work at all with Bitlocker where every encrypted sector will be completely unique and uncompressible. So if you're planning on using an SSD, don't get a SandForce one, or if you do, make sure you can return it if you find that performance really degrades after you turn Bitlocker on.
Because Bitlocker does not really change the usage characteristics of the drive other than changing the data itself. For example, it does not cause the OS to write randomly instead of linearly. It should have the same impact on an SSD that it would have on platters. That is, I would still expect the 20% to 10% decrease in performance that Maximum found, as mentioned in the thread you linked to. Note that the speed of Bitlocker may be bottlenecked by either the processor or the drive. That is, if the processor can encrypt/decrypt faster than the drive can read/write data, then file I/O will occur at near the speed of the drive. If your processor is overtaxed, the processor may limit file I/O speed, although I believe hardware-accelerated cryptography should minimize the likelihood of this happening.
Update. Some tests claim lower impact on modern hardware. This URL. On Dell Inspiron 15 7577, Intel i7 7700HU, Samsung 950 Pro 256 GB, Windows 10 64-bit NTFS IC. Indication of performance penalty by Bitlocker on small random files, for example compilation process. VeraCrypt is bad, transient no need to encrypt, in-memory is fast, for example get more memory, script mount of in-memory disk and copy of files for compilation. Not encrypted. Encrypted by Bitlocker. Encrypted by VeraCrypt 1.21. In disk 2.0.9 in memory. About.
I do not know if what applies to TrueCrypt applies to Bitlocker, but on SSDs, TrueCrypt has a hugely negative impact on performance if you encrypt the entire disk. The root cause of the problem is that you can no longer tell the difference between free space and usable space because encrypted data and encrypted free space are both treated as data. This defeats both trim and anywhere leveling optimizations. The performance on reads is negligible, but on average you are cutting your write performance by half or more. There is some evidence that leaving a free empty partition, i.e. giving the where leveling algorithms, which factor into performance, room to work with, has a huge positive benefit, but trim does leak data and can theoretically be used to compromise an encrypted partition by someone with enough resources. Edit. This might no longer be true because of trim pass-through features that now exist, but there is a lot of very tangled information out there when Googling exactly how this behaves. I would love to see some actual benchmarks with TrueCrypt 7.0 and FDA. Older versions of TC will display the problems I talked about above, but I cannot find any. Edit 2. Some years later the situation is now different yet again. Almost all SSDs encrypt the data before writing it because you want your data at the physical level to have high entropy. In most drives the keys to do this were not user accessible. Now with Opal they can be set by the OS to give you ICE encryption for no performance penalty. You need both OS and hardware support for this to work.
If you want to support the channel, please consider subscribing.